Hey, good afternoon, everybody. Thank you so much for taking the time to join us. We're going to give it another 30 minutes or 30 seconds to a minute to let some other stragglers join us, and then we'll get started. But again, thank you everybody for joining us, and we'll get going here in just a sec. All right, I'm sure we'll have a couple others join as we kind of get started here. But once again, thank you everybody for joining us this afternoon. My name is Benton Cook. I am the business development manager for DoubleRadius. We have two of my esteemed colleagues within the industry here, two very knowledgeable and just all around smart dudes, in Erik Randall and Bob Stone with Buy Cells. They're going to be the majority of the speaking today, so you don't have to listen to my voice too much longer. I'm going to do a quick introduction of what's going on today and then pass the microphone over to those two guys and let the experts get at it. So again, thank you guys so much for joining us. My name is Benton Cook. Today, we're going to kind of take a look at shedding a little bit of light into the educational space. Obviously, today's buzzwords really focus around that private LTE and 5G. So, what are schools doing today? Why should they be looking into this space? And what can they do with a partnership with Buy Cells and DoubleRadius to kind of accomplish what we feel needs to be accomplished within this space. So real quick, DoubleRadius, for those of you that do not know who we are a master distributor for all things fixed wireless and beyond. So everything from the radios to the cabling, to the routing, to the switching, to you fill in the blank, anything that the fixed wireless world and beyond does, we are distributors for that. Obviously great partners with Buy Cells and have been for years now. But we have been in business since 2001 as a company. We are located in Charlotte, just outside of Charlotte, North Carolina, in Indian Trail, about 20 minutes or so from downtown Charlotte. This is where the headquarters are: sales, logistics, operations, finance, everything is located here in Indian Trail. We also have our major main warehouse here, but we also have distribution centers in Utah and Canada. So depending on where you are across the continent, we got you squared away. So just let us know whatever you might need, and hopefully we got something close enough to you to cut down on ship time. We're solution providers. That's the big thing DoubleRadius likes to push. We're not just pushing out a box. We want to push out a solution. Let's make sure we measure twice, cut once. Whether you're a WISP, an MSP, a system integrator, fill in the blank, we hopefully have a solution for you and would love a chance to talk to you about your business and what we could do to help. We work in all verticals. One of the things we really like to make sure we get across is there's nothing we can't touch, whether it be service providers, education, state and local, municipalities, hospitality, MDUs, and obviously many, many more. So no matter what your goal is, at the end of the day, hopefully we have a solution for you. That's kind of who DoubleRadius is. I'm going to do a quick intro of our esteemed panel today, and then we'll get going. First and foremost, we have Erik Randall. Erik is the channel manager for Buy Cells North America. He's one of Buy Cells' strongest technical resources. He's all about education, championing the use of private LTE and the benefits it provides. Well over 20 years of experience in the wired and wireless technologies. Erik is a solution-based, kind of like DoubleRadius, very much a solution-based approach to ensure that every network operator has a complete end-to-end understanding of the hardware and technology they need to leverage to accomplish their deployment goals. Also a big fan of chickens and proud owner of some chickens. So if we have time, we'll get into how the chickens are doing. But also, we have Bob Stone with us as well. Bob is a director of carrier markets, similar to Erik. He's been doing this for well over 20 years, so experience within the wireless market, specializing in LTE connectivity solutions. Been a driving force within Buy Cells for the past 5 years, establishing the private wireless networks for school districts and cities across the country. Most notably, Bob and the Buy Cells team just led the charge to deploy a private LTE network within the city of Los Angeles and across the state of Utah via the Utah Education and Telehealth Network. His ongoing efforts include bringing private LTE networks to ports, libraries, and municipalities, which he's accomplishing with great success. So as you can tell from the accolades that I just listed, these two guys know what they're doing. They know their stuff when it comes to private LTE. So I'm gonna step back and turn my camera off so you don't have to look at this amazing beard anymore, and hand the floor over to Bob and Erik and let them kind of run with it. So have at it, gentlemen.
All right, thank you for that kind introduction. Bob, I'll let you introduce yourself, then I'll just start flying through these.
I don't think I need much more introduction. I think Ben did a fantastic job.
All right, perfect, perfect. So, like Benton mentioned, I'm Erik Randall. Bob Stone's going to be alongside of us. Today, we're going to do a little presentation on buy sells, how we make things easy, and how it could be right for any situation, especially the education market. Um, so quick about who we are, what we do, and why we do it. So we are buy sells. We've been here in North America now for about 7 years, globally for about 8 years. What we offer is an LTE solution. We offer products and we offer solutions. So with LTE, it's standard space. So you have interoperability to pick and choose what you want to do. We offer the entire end-to-end solution, or you could buy us for one piece of that puzzle. And we'll actually get into scenarios where people deployed us holistically or just one part here and there. Why do we do what we do? It's actually fairly simple. Our founder comes from the carrier grade Huawei, and he found that, a cheaper solution is what needs to happen out there. So he went out and started his own buy sells, and started providing an easier way to understand LTE and then a cheaper way of getting LTE to each location. So again, we're globally established innovator, over 10 plus tier one operators. We operate across the world, 60 countries. Here in North America, we have over 800 network deployments. And then a quick little blurb about our global footprint, our different partners throughout the world. So we're partnered with Qualcomm for our chipset. We work with Facebook, China Mobile over there, True Wireless. We play across the entire industry across the globe. So how does buy sells make private LTE easy, and what is private LTE? So private LTE is taking that Verizon, that AT&T, that T-Mobile network, taking all the knowledge, all the research that they put into LTE, and it's bringing it locally to your network. So you have all that in your own small little network. So that's LTE. And what it provides you is the cost benefit, because it's standard space. You could pick and choose which pieces you want. The quality of service, you could say, hey, these doctors here, they need a greater piece of the network than, say, the medical robot going throughout the entire hospital. You could pick and choose what you want from that. And the security, it's unmatched. Because of the SIM authentication, it's not hackable. So again, private LTE, it's having your own private core, not going back to Verizon, not going to T-Mobile, not going to AT&T. In North America, we have two primary bands we work with for private LTE: band 48, the CBRS band, or band 41. So the CBRS band came across a few years ago to where the general public now has access to spectrum, and inside that spectrum, you could actually utilize LTE. Um, the the certification process is with OnGo, and they've certified over 600 LTE devices for band 48. So this is an iPad mini, the LTE version. This will actually work across my buy sells network here at the house.
Erik, I'm going to make a comment on that slide before you jump ahead.
All right.
So what CBRS is doing, for those of you that aren't familiar, is before CBRS came along, the discrepancy between what we are able to do with private networking versus what the carriers could do in the public network was vast. LTE technologies, the non-line of sight capabilities, the security, the things that you're able to do on a carrier network are night and day versus what we were able to do with our unlicensed frequencies with a Wi-Fi based solution, 2.4 gigahertz, 5 gigahertz. So what CBRS is doing, these are clean channels that were negotiated. This is in the 3.5 gigahertz band that was reserved for the U.S. military, and they were using it for radar systems to guide ships into port. But otherwise, the frequencies are sitting idle. Meanwhile, here we are. As we continue to grow, we need more bandwidth. We need more. Everyone's on their devices. Everyone is, streaming videos, and there are more and more applications that require more and more bandwidth. So gone are the days where we can sit and have idle frequencies. We need to find ways of leveraging the frequencies that are available to us. So the FCC negotiated with the military to pull back 150 megahertz of frequencies for use in CBRS. And this allows us now to deploy carrier-grade LTE deployments without having to spend the billions of dollars that the carriers spent on their license frequencies. T-Mobile with their 600 megahertz, Verizon 700 megahertz, 2.5 gigahertz, etc. They spent billions of dollars at auction to have these licensed frequencies that only they can utilize. Meanwhile, the rest of us are using 5 gigahertz, and everyone under the sun has got an access point, and you've got limited range. You're subject to interference and spotty coverage, and you can't put anything of critical nature over that type of infrastructure. So now we are enabled with a new frequency that is shared that allows us automated management between devices instead of kind of the cowboy interference that we're used to in Wi-Fi, where anyone can put up an access point. So now with CBRS, there's a hierarchy, and like I mentioned, there's 150 megahertz to utilize here. The slide to the right here shows T-Mobile, Verizon, AT&T. Their entire networks are built on mostly less than that 150 megahertz of available frequency. So this is a nice piece of spectrum that we have to utilize. Go ahead, Eric.
And
All right,
real
thank you.
quick, Eric, before you continue, I meant to mention earlier, for those in attendance, we are recording this, one, but two, we want this to be interactive. So if you come up with questions as we come along, please put them into the question box, and then we'll be asking them as we go. But use this as an excuse and an opportunity to really learn and educate yourself. So if you have questions, please don't hesitate. If you want to take them off session afterwards, feel free to reach out to myself or either one of the buy sales guys. But real quick, Eric, I did want you to, we have a question coming. I want you to clarify. So somebody had asked if buy sales was a Chinese company because you'd mentioned about Huawei. So I want you to
Correct.
clarify.
So even though we are a Chinese company, we are TAA compliant. And if you ever have questions about that, we can get you that TAA compliance notice. So we are a Chinese-based company. Go ahead, Bob. You're good.
Yeah, I was just going to say, yes, we're TAA compliant because all of our devices are manufactured in Taiwan, which is a TA certified country, and we are also we use all Qualcomm chipsets. Qualcomm's an American company. Qualcomm is an investor in buy cells. So we are very heavily tied to the U.S. and the deployments here. Our headquarters, our U.S. headquarters are in Plano, Texas. Our support headquarters are up in Madison, Wisconsin. Our CTO is in Madison, Wisconsin. So we are very heavily tied to the U.S. market, though our parent is headquartered in Beijing. We do all of our manufacturing in TA compliant countries and are utilizing US-based chipsets.
Okay. Thank you. All right, so a little bit more.
I'll continue what I was saying. So on the CBRS frequency, I mentioned that we pulled these frequencies back from the U.S. military, who was only using these frequencies to guide their ships into port along our coastal cities. But when they agreed to let these frequencies be utilized by the general public, they said, okay, we'll do this, but we want the first right of refusal if and when we ever need that. So what CBRS did, they came with a SAS system. The Spectrum Access System is basically an automated system that gives you permission to transmit, and there is a hierarchy. So every one of us, we're going to live in this bottom tier, the GAA. It's free to use this. When you put up your network, you have a certified installer put in their credentials and say, okay, I'm putting in this base station at this location, geolocation, at this antenna height, and I'm radiating at this power. So the system knows who's radiating in that area and if there are clean channels available, and you request a channel from the SAS. The SAS finds a clean channel for you to operate in, allows you to transmit there. You are now operating your network that is your channel to continue using potentially forever. unless you run into someone at a higher tier level that is transmitting at the same time you're transmitting on that same frequency. Then, so our system maintains a heartbeat, it's called, to the SAS, where it operates. I like to liken it to that child game, Mother, may I speak? Yes, you may. Mother, may I speak? Yes, you may. Mother, may I speak? No, someone else is talking right now. You're going to have to wait or move your frequency. So in that instance, there's a second tier called the PAL, which is the priority access license. These were auctioned off by county. So every county across the country had the option to put in for bid 10 megahertz frequencies, and any given entity, say, Verizon was a bidder, Cox Communications, San Diego Gas and Electric, there were a few, major bidders, and a maximum of 4 10 megahertz channels could be won by any given agency, and a maximum of 70 megahertz total per county, which means there's still 80 megahertz of clean channels if in your county every single PAL was auctioned off, which that is not the case in most counties. But even if that was the case in a major city like Manhattan, then there's still 80 megahertz of clean frequencies to operate in the GAA. And like I said, we do still have that whole entire 150 megahertz to operate in. You only have to switch channels or wait if you have a collision with someone with a higher tier access than you at that time. One other thing to note, I did mention in Manhattan, the incumbent is the U.S. military when they're guiding their ships into port. So they get priority. You need to use those frequencies when they so choose. Well, we happen to be doing a trial with 8 other vendors in New York City, Manhattan, and this was something I wasn't aware of at the time, but they happened to have a military naval parade in Manhattan while we're doing this test. And all 8 vendors lost their frequency during this parade that was coming through. And of the 8 vendors, Bicells was the only one that came back up because we put an algorithm into our system that searches and will apply a new channel. None of the 8 other vendors did that. So that was actually something I learned because we had that issue come up. And like I mentioned, these are frequencies that were given back to us by the U.S. military. They only operate in these coastal cities. So for most of us in the interior of the country, this is never going to be an issue. Go ahead, Erik.
All right, thank you. So moving on to the architecture of private LTE, you essentially have three portions of the network. You have the network core, where that's where your network manager sits. That's where your evolved packet core sits. That's where your internet comes into your network core. That evolved packet core, just to make a quick explanation of it, is where your SIM cards are provisioned. So you provision your SIM cards on that evolved packet core. You create your service plans there. Everything's done on that EPC. From there, you move over from the network core over to the radio access network, the RAN. That's where you have your eNode Bs, whether they're indoor or outdoor, your fiber transmissions. All of that is part of your radio access network, your RAN. Then you have the UEs, the user equipment, the terminals. And within there, you're going to see different CPE devices, CPE being customer premise equipment, and user devices and all kinds of smart devices. So examples of that, I always have one up and ready. We have an ID15 from Bicells right here. This is considered a CPE. And then an end user device being more like an iPad like this here. So there are over 600 certified devices to be used in CBRS today. And that list actually grows pretty much daily. So how does Bicells make that architecture different? How do we make it easier? So if we look back, the network core, we have the network manager with an on-site server. We have the evolved packet core, again, with an on-site server. We take both of those functions and we move them to the cloud. So the network manager, we call that the OMC, the Operations Management Council. The evolved packet core, we call that the BOSS, Business and Operation Subscriber System. So we take those functions that, high capex, and we take that and we move it to the cloud to help get you going, to help get you learning about LTE quicker. Everything else is the same. So you'll see the RAN still the same eNode Bs. Your terminals are still the same terminals. You just changed out that network core from on-site to a remote cloud type environment. All right, so a basic comparison of LTE in CBRS to Wi-Fi. So the wireless spectrum for CBRS, it is licensed through the SAS, so you minimize the interference. Wi-Fi, we all know what happens with Wi-Fi. There's a lot of interference there. The signal coverage with LTE reaches about 4 times farther than Wi-Fi. And to discuss that, with the signal.
And that really is with like devices. We are talking about your cell phone type devices or iPad 4 times the range. But when we're talking about a fixed device, we can get many miles, 6+ miles, which is much greater than you can do with Wi-Fi.
Mm-hmm. Exactly. So you have indoor units like this, LTE eNode B. This is an indoor unit. This will get you 4 times the coverage that a typical Wi-Fi AP would get you. I'll set that over there. The connectivity performance, it's ideal for low latency, LTE. It thrives when it's connecting to more and more people. Whereas with Wi-Fi, the bandwidth will deteriorate when you start adding more. The security, as I discussed earlier, the SIM authentication makes this pretty much unpenetrable. Whereas Wi-Fi, we're always seeing new AES come out because the last version was hacked. And then the device ecosystem, yes, everything has Wi-Fi. Everything and its brother has Wi-Fi. But with LTE, it's emerging, 4G, LTE. They're buzzwords, 5G, buzzwords that people want to talk about, that people want to get involved with.
Hey, and Erik,
so
we actually
on that. Sorry, go ahead, Ben.
Yeah, no, we had a quick question come in regarding the SAS. So regarding the SAS, when it comes to a fixed wireless network opposed to a private LTE network, is there a cost difference associated with the SAS from one to the other?
No, it's the same. So the SAS providers, there's a few of them: Google, Federated Wireless, Sony, and Amdocs. CommScope was one, but they bowed out of that game, so now we're down to 4. Each of them have their own kind of special sauce that gives them some kind of an advantage. They all are similar in price point, but I know Google SAS is charging about $3 per eNode B. So if you build a network, you've got a school district that's got 26 district buildings, and we put a site up at each of those, you're going to pay $3 a month per radio on that network.
Perfect. All right, so we'll get into some use cases now. Part of BuyCells is being able to build the smarter community. So whether it's a public Wi-Fi, video surveillance, home learning, all of those can be had with private LTE. So we're going to go into a couple of highlights, and then we'll get into some of the use cases. Bob, you want to take over now?
Sure. So on this slide, what are we using private LTE for in school districts? Well, the obvious answer, back in 2020 when the pandemic hit and all of a sudden our students had to go home and somehow maintain education, it was shocking to learn how many students didn't have connectivity at home. One of our case studies that we did with a school district after doing a deployment, one of the ladies that we interviewed was in tears when the school district finally made this offering to her, because her 2 sons were falling behind in their schoolwork because the only internet access they had at home was her cell phone, and she had to pay for a higher plan just so her 2 sons could do their homework. And it was too expensive. She couldn't afford it, and they were falling behind on their schoolwork because she didn't have enough data on her plan. So when the school district came to her and offered this free access that provided by the school district, she was in tears. It was something that was a lifesaver for her and her family, her sons, to be able to get the education that they need and deserve to grow up and have a life and a good education. So, but that has evolved now. So we started in 2021 with several school districts across the country, and very rapidly we're able to deploy these LTE networks. And that device that Erik showed earlier, that little tower-looking device, we had devices like that sent home to students with SIM cards, and that device that he has is also Wi-Fi enabled. So this connects to the LTE network that's radiating from the school building, and those students take that device home. They put it near a window at their house. It can connect at home, and then it radiates also an indoor Wi-Fi signal. So every device in their house that's Wi-Fi enabled can connect to that device and then go out over the LTE, and you have internet access at home, and you can do your schoolwork. Well, that's how this thing got started. But since then, what now? Now we've gotten our students online, and now our students are back in the classrooms. But how does this evolve? Where does this go? What are we able to do? Well, we'll turn the page and we'll get into a couple of our use cases that some of the school districts that we're working with, and where they started and where things are at now, and what they're doing. So this case study is the UETN. This is the Utah Education and Telehealth Network. This is a statewide fiber provider in the state of Utah that provides bandwidth and other services to every education and telehealth agency across the state of Utah. Well, early on, actually even pre-pandemic, we were working with them on some use cases, and because we had done some testing and we were a bit down the path already, they were ready. When the pandemic hit, we were very quickly able to get a network up and running. The UETN purchased a hosted core, which allows every agency, school district and telehealth agency across the state to purchase and deploy their own LTE network, but use the hosted core of the UETN. What did this do? So now, because they didn't have any CapEx or even OpEx on the core side of this network, Murray School District and Wasatch School District were really two of the early entrants in the state of Utah. They were able to put up bicells eNode Bs. The photo here is our Nova 436Q, just on a sled on the roof of the building, radiating with antennas out, 360 coverage. And Murray School District, their entire school district was covered with LTE signal within months of the pandemic starting. And like I said, that device that Erik showed, that device was handed out to students. There's also a wealth of other vendors out there that make devices that have their own advantages, that are part of this LTE CBRS ecosystem. So some of those devices were also handed to students. They also now have Dell and HP laptops that are enabled with CBRS. They connect direct to the network. They have tablets, iPads, Samsung tablets, various devices, a wealth of devices that are now being handed out to the students. Well, Murray School District, their students were online very early on in the pandemic, and they were kind of the poster child for LTE in education. Well, what are they doing now? Well, now their network has grown. They're working with their local county. They just were actually 2 weeks from now, we'll be there visiting them. They're working with their county on I've got a 190-foot tower that the county owns that they're going to be putting multiple sectors of BiCell's radios to expand the network, give them more bandwidth and give them more connectivity throughout their county, and working with the county to have county agencies also be part of this network and use some functionality. Some interesting use cases that they've done, not only do their students have these devices, Murray School District, they have coding classes. Every one of their students that is that is doing coding has an iPad that is Band 48 enabled, and they do all their coding over the LTE. Because of the low latencies, the high performance, the range they can get on it, it is much better for the coding work that they're doing than the Wi-Fi is. So that's one use case that they've got there. They also have built a stadium now where they're doing competitive esports, competitive gaming. And this requires high throughputs, low latencies, and this is something that they're able to do over this network. So there's more and more use cases that are now coming from what they did initially with the pandemic to get their students online, but now there's a wealth of things that they're doing to bring a better education to their students. They're using LTE as innovation to give better education to their students. Go on to the, well, actually, I'll comment one more on Wasatch, which is also part of the UETN. Across the state of Utah, we have, I believe there's more than 12 school districts currently deployed and several others that are getting ready to deploy. One thing, because they're using a hosted core within the school, within the state, that student that was given that device at Murray School District and is provisioned to what he is doing in his classroom at Murray School District, he can take that device and be on the other side of the state and connect to the network deployed by Wasatch School District or Salt Lake City School District or any other district that has this network deployed, and he can connect, and it routes him back to his Murray School District, everything he sees that he's provisioned for at Murray School. He's on the opposite end of the state, and it's as if he's sitting in his classroom. So that's one thing that's, another, layer of innovation that's happening in Utah. Wasatch now, they built their network. They got their students online. Wasatch is a community that is growing very rapidly. It was a small town at one point, and the school buildings that they built was for their population. Well, with everybody leaving my state of California and going to Utah, they're now their city has grown very rapidly and much faster than they could expand their school buildings. So they actually had trailers out on the football field that were hosting classrooms because they had more students than they had availability to house and educate. Well, the pandemic was able to get their students online and give them some breathing room while they're expanding the buildings on their footprint. When they were starting to bring schools back or students back in, they could do a rotating classroom schedule where some of the students could actually stay at home and do their schoolwork. And anybody who's sick, stay home. Don't come back in for sure. So now they've got this ability to maintain education without having to put people in trailers out in the lawn or whatnot. Well, now they're working with their county. The county of Wasatch is so happy with and interested in what the school is doing. They've found funding. They want to expand the network, and they want every city-owned vehicle in the county or city of Wasatch to be on the LTE network. They want garbage trucks, snow plows, fire rescue, everything to be able to have connectivity on this private LTE network. And this is happening across the state of Utah and really in many other school districts and regions that we're working with across the country. Go ahead, Erik.
And real quick, I want to jump in and just kind of throw something. And Eric, maybe you can touch on this a little bit. Obviously, the use cases it will continue, but something you mentioned, Bob, that maybe Eric you can expand on just a little bit. You know, you had mentioned how UETN had kind of started down the path of private LTE before the pandemic had started. What are some of the things that maybe people might want to look at for reasons? Obviously, with the pandemic, that's spurned a lot of this. But even before that, what were some
Murray
of what are
School District, for one, is they're innovators. They want to provide the best education for their students. And I mentioned the use case of, their coders they're all doing their coding on the LTE, the esports that they're doing. They were forward thinking and looking at private LTE even really early on, just to educate themselves. What is this CBRS? And they're actually teaching LTE networking in their schools, and students have Bicells radios that they're provisioning and learning how to be an LTE service provider. Whether that means they end up an engineer for Verizon or Ericsson or whoever that may be, they're learning about LTE from the network that we've deployed in their school.
Exactly. So the use cases truly been are endless. Autonomous vehicles. You could set up an LTE network to communicate back and forth with autonomous vehicles. Oil and gas, for instance, you could set up.
That's actually a good one there too, because there are robotics classes as well, and having the robotics on the LTE is also so it's an advantage for their students with this over a competitive school that is doing Wi-Fi only.
Exactly. All right, so we'll move on. Quickly talk about the city of Vegas and Longmont.
And in city of Las Vegas, again, we were talking to Las Vegas pre-pandemic about smart city applications. But when the pandemic hit, Clark County School District, same problems that we had in the state of Utah. The students needed to be able to get online. So the city of Las Vegas stepped up and provided this network to Clark County School Districts and deployed these radios. This is on the rooftop of a fire station, 4 sectors, 4 antennas. They've got several. They deployed over 50 sites within 45 days to give coverage to the students in Cook County School Districts. Since then, when they got the students online in a very short amount of time, then they fell back and started expanding on the network and layering on the smart city use cases that they were thinking about before the pandemic. So in Las Vegas, they've got video surveillance cameras. They've got they're working with the Metro PD. They all have their cruisers and their command vehicles all have devices in the vehicles that connect to the carrier networks, but those devices are also band 48 enabled, and they prefer to be on the private network because now you're not paying your data minutes to the carriers. And that is actually a major use case for the school districts themselves. The school districts are providing carrier MiFi devices to the students. There are also many school districts have done school bus Wi-Fi, and the school bus Wi-Fi have these similar devices that these police cruisers have that connect to the carrier networks, but you're paying huge sums of money for the carrier minutes that you're paying. By building the private network, you still have the failover. You still have the ability to operate on the carrier network as needed. But when you're on the private network, you already have fiber to your building. You've already paid for that bandwidth. Sharing that bandwidth over your private network, the return on your investment is very short order. I was speaking with a school district just yesterday who has 64 schools in his district, and he didn't give me the number, but he says they're paying $40,000 a month just on MiFi devices alone to their student body. So to build out this network and hand out these devices that are on the private network and saving $40,000 a month, I think the ROI on a deployment like this could come back in pretty short order. But then again, just to finish up on Las Vegas, they now have, parks that are deployed with video surveillance. There's one use case that I find kind of funny. There's a statue near downtown that people love to climb on it and take selfies, and so they've got this kind of RoboCop, thing that's going over the private LTE. It's like, back away from the statue. The police are on the way. But it's just another use case layered on to the private LTE. But it started with the school districts, but then you partner with your cities and you're able to grow this network, and you get multiple funding sources that way. Like I mentioned, in Wasatch County, they had budget from CARES Act to get this thing started, but now the city and the county are throwing money into it to grow this network, and that only gives you better ability to reach your students. Go ahead. Next slide.
Well, real quick, I want to jump in with a couple questions that have come across, and we'll kind of keep it moving. But one of the kind of quick, easy questions is, what kind of bandwidth are we saying when we say 5G? What kind of bandwidth can we expect?
Well, so we've got an array of different platforms, and you also have different channel widths that you can use. So depending on the congestion of the area. Our radios can do carrier aggregation, so typical deployments, in the case of Las Vegas, since we're on this slide, every single one of these 4 radios is a Nova 436Q. They've enabled carrier aggregation, which uses a 20 megahertz channel plus a 20 megahertz channel, and they bond those 2 channels. So each one of those radios is able to transmit about 440 megs on the downlink, and I'm forgetting off the top of my head on the uplink. Erik, do you know that?
On the uplink, just under 30 per node B.
Per carrier, though. So carrier aggregation doubles that?
No, I have already doubled it. It's right around 30 with the carrier aggregation.
Okay. So that's on this radio solution, but we also have, since this deployment, and actually Las Vegas is now in the middle of an expansion, which includes our Nova 846, and we'll get to the products. So we're kind of going through use cases, and then Erik's going to go through some product slides, so we'll get into more detail. But our Nova 846 is an 8x5 watt radio that's true 4x4 MIMO, 256 QAM, so it has higher bits per hertz data rates on that radio, so we can get even greater bandwidth there. But like I said, I don't want to get too deep into that because we've got product slides that we're going to get into.
All right.
And then the last use case, very similar situation. The school districts started initially with this need, and even school districts that didn't start their deployments. So this is St. Vrain School District in the city of Longmont. They didn't start their deployment early in the pandemic, but the pandemic was a realization. So they knew that they needed this network. They did use some budget to get MiFi devices, but now that's coming to haunt them. So they wanted to get off of the MiFi devices, build this private network, and be wholly sufficient to provide access to their students. So they've started, putting up 29 sites of the BiCells radio and getting these, radios. They're on our cloud core. They're really using BiCells as an end-to-end solution, but also have third-party devices, MiFis, laptops, and whatnot that are Band 48 enabled to connect to the network. But very quickly, the city of Longmont got involved, and similar to what's happening in Las Vegas, they're very interested in what the city is, or what the school is doing, and they've added monies into it. And now the city of Longmont has furthered this deployment. They've now got over 37 sites deployed, but they started with parks. They've got they put up video cameras throughout the parks that are all backhauled with BiCells, eNode Bs, and they have a shot location technology that operates with these video cameras. Very early on, they have already had 3 arrests for crimes that happened in the park. They have video evidence of this and getting convictions, all because of what they were able to do over this private LTE network. So they're continuing to expand on that. This was all done in 2022. They've allocated now 2023 budget to continue this, to build this LTE network out, citywide throughout Longmont.
Yeah, and Eric, yeah, I was about to say we have about 15 minutes left, Eric. If you don't want to go through the product portfolio, see if we can't knock out a couple questions before we get out of here, and then we'll wrap up.
Yeah.
Yep.
So I'll knock this out pretty quickly. So our product portfolio, again, we could do everything or we could do one little piece of it. So we have outdoor, indoor eNode Bs or base stations. We have the MiFi routers. We have PoE routers. We have basic Wi-Fi devices. We have the local EPC, local network manager, and we also have cloud-based solutions. So with our outdoor eNode Bs, they're all 3GP compliant, and they all have different functionalities to them. All of these that you see up there, they all play in band 48 except for the Nova 452. That plays into the actual education broadband spectrum of band 41. And they each have their little go-tos. So for example, the Nova 230i right here in my hand, it's tiny. It is a single carrier though, gets you about 110, 150 megabits per second. The Nova 430i, you get that carrier aggregation, that 30 megabits per second across the sector at only 22 to 25 watts of power consumption. Nice and easy, get you 3 miles of coverage pretty easily. The Nova 439 is an all integrated 360-degree Omni antenna. And then you have our connectorized ones right up top. The 846 and the 452 has that additional power and band 41 to get you farther. Whereas the Nova 436, it's going to max out what CBRS allows. And all 3 of those products, they do the 256 QAM, they do the carrier aggregation, but the Nova 452 and the 846, they do that 4x4 MIMO to help you increase that speed even farther, so even more throughput. Our 5G, someone was asking about 5G with throughputs and bandwidth. So with 5G, we do have a certified 5G product in the Aurora 243. And what it does in N48 right now is going to still be 40 megahertz at N48. And that's going to get right around 350 down by 150 up. So you see a huge improvement there on your uplink. When 5G takes farther hold and you're able to get a hold of more spectrum, 100 megahertz, you can expect to see 850 down in 4x4, 1.5 gigabits down, and about 330 up. And then you can see there the active users, it's soaring at 200 active users per eNode B.
One quick caveat on the 5G. We mentioned earlier the ecosystem for CBRS, and more than 600 devices that are certified for CBRS and LTE. The 5G ecosystem is still very young. So though we've got the radios to deploy for 5G in the CBRS spectrum N48, the ecosystem is still very young. So a lot of these, laptops and cell phone type devices that we've, commented on for the LTE deployment are not yet available for 5G. The 5G ecosystem is young.
Perfect. So on the indoor side, we have that Neutrino 430 that I was showing you a little while ago. It can also work in carrier aggregation mode, 300 megabits per second. So some spectrum coverage, you see that we do have a little bit more on the heat map compared to other LTE manufacturers. And if we looked at Wi-Fi, it would be significantly more.
Yeah.
This slide needs to be updated to 300 megabits per second. But outside of that, everything else is pretty much correct. All right. On our actual CPE side, the customer premise equipment, we have a mix of outdoor category 6 and outdoor category 15. And the greater the category, normally the more throughput, the more features you get. On the indoor side, we have a pocket router. We have the ID15 here in my hand and the ID06. So ID stands for indoor, OD stands for outdoor, and then that 06 at 15 stands for the actual category itself. In our Wi-Fi family, we have a Snap PoE router that has a 24-volt passive device. So If you have devices you're trying to feed 24 volts to, this device will do that for you. If you're waiting for backstock of another company, we truly can help fulfill that order. And then we have your typical consumer grade Wi-Fi 6 mesh router. So I ran through that product portfolio pretty quickly, so that way we can get to the questions. We have 10 minutes. So if there are any other questions, let's go ahead and get those sorted out now.
Yeah, so there's a couple that kind of center around the same thing, so I'll kind of just generalize it. Um, a lot of it is kind of line of sight issues. If you don't, if you're not in an area that has flat terrain or down in a valley, but then also how does that look as far as the deployment goes, and then also kind of piggyback off of that is from a mounting standpoint. If you don't have private towers and whatnot, where and how are you mounting these radios within an ecosystem?
Okay,
So Eric, will
so
you jump back to that product page so we can kind of talk through this?
this one here.
That's kind of why we've got kind of a varied portfolio here. So so the Nova 846 is the 8x5 watt radio. It's going to have external antennas. This is the one that's going to best be able to kind of blast through trees and get you the best signal out on the edge. And when you're looking to get range, narrowing the antenna beam is the best way to do that. So we've got deployments up in Northern California where every school building has a 6-sector deployment, and they're using very narrow beam antennas, 33 degrees and 65 degree antennas to kind of shoot that sector radiation out as far as you can, and it really does a great job burning through those tall trees they've got up in Northern California. So that's their methodology of getting that best signal. And all of these school rooftops that we're able to get on, like all across like Murray School District in Utah, he just put he's got flat roofs, so he just put a sled with a 15-foot mast on the roof of his building, and it's just held down with cinder blocks. So that's kind of the light, easy way of doing this. The ones that I had mentioned in Northern California, they've got some tilted roof that actually required some roof penetrating mounts, and they were actually able to go up 25 feet by putting those roof mounts on. And a lot of them also use other assets. So we mentioned partnering with the cities. Fire departments are always happy and willing to partner with you and let you get on their roofs, or they often have towers on their property. And also the high schools. Your high school football field has stadium lights. Stadium lights are beautiful for radio deployment towers. Most of our deployments that we have with these school districts, a lot of them use some stadium lights to hang radios up there.
One of the bonuses of that, Bob, too, is your power is already there, right? So a lot of times,
yes.
How are we going to power these radios, especially from a rooftop or a rural area? Looking at something like a stadium light, your power's there, so that kind of comes in handy.
Yes, 100%. So Eric, if you jump back to that product page, I do want to talk about another radio. So that is kind of the hit the back button down on the right. There you go.
It didn't work with me.
So the line across the top are external radios, high power, the highest of that in CBRS, that Nova 846. So that's the one to, if you really need the range and penetration. Now, the bottom three are the all integrated solution. And these have, built-in antenna, they're power over Ethernet. So it's very quick, simple, and easy to deploy these radios. We call these a zero footprint installation. But the most powerful of all of these is this Nova 439. It's a 4x2 watt radio with a 360 degree integrated antenna. This thing can pop up anywhere and give you, the full radiation pattern in a single radio. So it's not going to give you that as great a range and that deep penetration that you can get with the external radio platforms when you narrow that beam to really kind of push the signal out. But it's quick, it's easy to deploy, and you can put several of these. So what we see in most of our deployments is some kind of a combination. You'll have a couple of spots where you can get on a tower, some vertical, asset, and radiate, the wider signal. And then where you've got some coverage gaps, you put in one of these integrated solutions that you can mount on a pole anywhere, and it's a very quick and easy install.
Awesome, thank you. So real quick, we'll do one more question and then we'll wrap up. For the people in attendance, Mike and Joshua in particular, I see your questions. They're a little more specific. So what we'll do is we'll take those offline. Myself, Eric, Bob, one of us or a combination of us will reach out to you afterwards and talk about your specific projects you guys are asking about. But real quick, Eric, I wanted to chat real quick on the ROI because we had another question kind of centered around that. And in comparison to maybe a standard Wi-Fi model that everybody's used to, or if you just want to break down how BuyCells does it with an ROI standpoint from a deployment on private LTE versus your traditional Wi-Fi.
Yeah, so with ROI, we could take something like the city of Vegas, for example, and we'll just use this as an example. So with what they did, their proof of concept was actually 4 radios with 4 antennas. So 4 radios, 4 antennas, and 100 users, just for an example, cost them right around $30,000. You have 100 working customers at $30,000. You break that down, and you're looking at $400 per customer. I mean, do the math there. If you charge $80 for your internet, you're looking at 5 months. You charge $30 that you can get from the government, you're looking at 11 months. So with BuyCells, the ease of use, the ease of operation, the less expensive solution, your ROI turns into profit pretty quickly.
And further comment there, in Las Vegas, they were going for more bandwidth and a more robust deployment from the get-go. We do have ability to have kind of more of a pay-as-you-grow model. So in this scenario with this deployment, you've got 4 radios and 4 antennas maximizing the channel bandwidth per sector. However, all of these external radios that we have the capability of doing dual sector mode. So instead of doing maximum bandwidth per sector, you can actually they're all dual carrier, dual channel radios. So you can actually split that up and have one radio going to 2 separate antennas. So see how you've got kind of a north and south antenna and an east and west antenna. You can each of that two antenna arrays can go to 1 radio, and you can remove 2 of those radios. So if you can do a kind of the split sector mode, you can still have the 360 coverage, but only from 2 radios because you're doing the split sector mode. You don't have as much cell capacity, but it's a lower cost of entry.
Exactly.
Yeah, no, I think that at the end of the day, the point of this webinar was really to educate, right? I think there's a lot of people that, again, have heard the buzz terms, the private LTE, the 5G, but maybe haven't really understood how to make it work in their deployments or in their opportunities. Maybe they're stuck with the standard thinking of Wi-Fi or even fixed wireless to an extent, but, being able to really utilize the private LTE and the 5G capabilities allow you to own your own network, really allow you to kind of take over from there.
Yeah, and of course, Wi-Fi is not going anywhere, but really, if for on campus, adding LTE for on campus, it enables you to do you put your more mission critical applications on the LTE, and most of the the Wi-Fi, it's kind of open access, it's subject to interference, very short range. But like, we mentioned some of these use cases like the coding, et cetera. You put that on the private network. All of the teachers are on the LTE for the security because they don't want, these very smart hacker students hacking in and getting the answers to the tests.
It's not as simple as waiting for the teacher to leave and just take the book like we were all used to. So
right.
Hey, well, gentlemen, as we approach the top of the hour, we'll wrap here. Again, Erik, Randall, Bob Stone, Buy Cells, thank you so much. Wonderful, wonderful job. I greatly appreciate the partnership and the webinar. Again, for anybody in attendance, we will be recording this, so we'll be sending it out through socials and whatnot. So if you have any questions, you see the email up there for Buy Cells. If you have any questions direct with them, feel free to reach out to me, Benton C, so BentonC at DoubleRadius.com, and I'll be more than happy to help you. Again, Mike and Joshua will reach out offline to get you guys updates and some information on the particular questions you asked. But once again, everybody, thank you so much.
And we're open to jump on a one-on-one call with you guys as well.
Yep.
So if you want to set that up, then fantastic.
I will. I'll make sure that we connect the dots there. But again, everybody in attendance, thank you so much for joining us this afternoon. Erik and Bob, once again, thank you, gentlemen. Always a pleasure. Hope everybody enjoys the rest of their afternoon, has a great week, and thank you again for joining us.
All right, thank you, everybody.
Thanks, everyone.